Hello and welcome to Selection Sathi. Today we will learn about trees and binary search trees. Trees are hierarchical data structures used everywhere, from file systems to databases. This is a high-weight topic in GATE CSE. Let's start with tree terminology. The root is the topmost node with no parent. A leaf is a node with no children. The height of a tree is the longest path from root to any leaf. The depth of a node is its distance from the root. The degree of a node is the number of its children. Important properties of binary trees. Each node can have at most 2 children, left and right. The maximum number of nodes at level k is 2 to the power k. A tree of height h can have at most 2 to the h plus 1 minus 1 nodes. A key property, the number of leaf nodes equals the number of internal nodes with 2 children plus 1. The binary search tree property says, for every node, all values in the left subtree are less than the node and all values in the right subtree are greater. This property makes search efficient. Search, insert, and delete all take O of h time, where h is the height of the tree. The Inorder traversal of a BST always produces a sorted sequence. There are 4 standard tree traversals. Inorder visits left, then node, then right. For a BST, this gives sorted order. Preorder visits node, then left, then right. Used to copy or serialize a tree. Postorder visits left, right, then node. Used to delete a tree bottom-up. Level order uses a queue to visit nodes level by level, which is BFS. Let's build a BST by inserting 8, 3, 10, 1, 6, 14. 8 becomes the root. 3 is less than 8, so it goes to the left. 10 is greater than 8, so it goes to the right. 1 is less than 3, goes left of 3. 6 is greater than 3, goes right of 3. 14 is greater than 10, goes right of 10. BST is built. Now let's do an Inorder traversal of this BST. Start at root 8, go left to subtree rooted at 3. Go left to 1, it's a leaf, visit 1. Back to 3, visit 3. Go right to 6, visit 6. Back to root, visit 8. Go right to 10, visit 10. Go right to 14, visit 14. Result 1, 3, 6, 8, 10, 14. Perfectly sorted. Searching for value 6 in our BST. Start at root 8. Since 6 is less than 8, go left to node 3. Since 6 is greater than 3, go right to node 6. 6 equals 6, found it. We made only 3 comparisons. In a balanced BST, the height is log n, so search takes O of log n. Finding the height of our BST. We use the recursive formula, height equals 1 plus the max of left height and right height. Leaf nodes 1, 6, and 14 have height 0. Node 3 has height 1. Node 10 has height 1. Root 8 has height 1 plus max of 1 and 1, which is 2. The height of this BST is 2. Key revision points. Inorder of BST gives sorted output. Use this to verify BST property. Balanced BST gives O of log n operations. A skewed BST degrades to O of n, so use AVL or red-black trees. GATE favorite question, Reconstruct a tree from Preorder and Inorder sequences. For more concept videos like this, download the Selection Sathi app. Like and subscribe. Thank you.